Hello, everyone. Welcome back to some more remote learning. Again, I'm Mr. Scull, one of the comprehensive science teachers. Yeah, we are going to continue with our study of the biological macromolecules. So if you remember, we have already discussed carbohydrates. There are four total, so we've already done carbs, so that leaves us three. We're going to talk about lipids for the next little bit. Then there's proteins, and then there's one more, nucleic acids, which we won't get into, I think, as much. But we're going to be focusing on lipids for the next little bit here. So let's talk. These are organic molecules, just like carbohydrates. That means that they are made primarily of carbon. They have a lot of hydrogen and not a lot of oxygen. So if you remember with carbohydrates, they had a carbon to hydrogen to oxygen ratio of 1 to 2 to 1. So for every carbon, there was one oxygen. Lipids have much, much less oxygen, and we'll look at why here coming up in a bit. One of the key factors of lipids is that they are not soluble in water. Okay, that means that they don't dissolve in water. They separate out. So there's two layers, right? So if you've ever seen oil and water mixed, whether it's, I don't know, gasoline or something, or an oil like a cooking oil, they don't mix, right? Uh, in your classes, this was months ago, if you recall, we had a graduated cylinder which it was called a density column. It had a number of different layers, right? Um, and water was in there, and there was soap and oil as well. And they didn't mix, right? They separated out. Lipids or fats is the other kind of way that we refer to them oftentimes. They do not dissolve in water. They'll always separate out into another layer unless you do something special to them. Why is that? Well, that's because of the polarity. Water is a polar molecule. We've talked about that before. The oxygen has a slightly negative charge. The hydrogens have a slightly positive charge, which overall gives you a positive side and a negative side. That's polar. Lipids, on the other hand, are nonpolar, almost entirely nonpolar. Um, all the different parts have the same charge, and so there's no poles, there's no opposite ends. And when things dissolve in water, the way that they dissolve is they line up. So all the positive ends of the polar bit line up with all the negative ends of the water, and all of the negative ends of the thing that's going to dissolve line up with the positive things of the water, and that's how it dissolves. Lipids can't do that because they don't have positive or negative ends, so they are not soluble. You have to remember that like dissolves like, and so polar things can dissolve polar things. Now, nonpolar things, they dissolve in a different method, so they can dissolve nonpolar things. So lipids could dissolve in a nonpolar solvent, but they can't dissolve in water. They separate. As I said earlier, carbon, hydrogen, almost exclusively. There is a little bit of oxygen, but it's barely any at all. So some examples of lipids here at the bottom. Fats. You have humans have fat on their body. There's all kinds of animal fats. Lard is beef fat. Tallow. Uh, I cook with duck fat. It's very yummy. Butter is a fat. So all those are fats. Oils, so these are primarily plant derived. Olive oil is a really big one. Soybean oil is used in cooking a lot as well. Grapeseed oil, sunflower oil. There's all kinds. Coconut oil is another one. Waxes, earwax, right? And then steroids. And these are, steroids are a really special kind of lipid. They have a really unique shape. The probably best known steroids would be the the sex steroids for humans, which are estrogen and testosterone. But your body uses all kinds of steroids. They're a way of transmitting information over long distances in your body. And these are all examples of lipids. So what do lipids do? Well, they store energy. That's one of the big ones. And that's one of the main reasons for the fat deposits on your body. These are long-term energy storage. And so we use glycogen, which is a short-term energy storage for carbohydrates. Lipids are a much longer term energy storage. And so our body puts on larger deposits of it to kind of, our body thinks that we're going to run out of food or whatever. And so it likes to create these stores with excess that we put into it. Heat loss and physical shock protection. So fats are insulatory. The whaling industry, which is going out and capturing and then killing and slaughtering a whale. I'm not sure how much it's used for it nowadays, but kind of back in the day, in the way back, this was a big reason for the whaling industry. Whales have large, thick layers of fat, which makes sense, right? A whale is a mammal. It's warm-blooded, but they're in the cold seas, and so they need a lot of insulation. And so they have these very thick. I mean, I'm talking about 3 feet wide of fat, just a massive layer along the belly. And that was to protect against heat loss because these whales would be in the cold waters of the Pacific or wherever they are. They go deep enough in the ocean, it gets entirely too cold for keeping internal processes going. So they have a lot of fat. So anyway, these whales, they would go out, they would get the whales, they would kill them, and then they would melt down the fat and they would use that oil for all kinds of things. Physical shock as well. And so for another thing for protection, so one of the things that fat does because of its structure is when it is impacted by something, it spreads out the force of the impact. So let's think about those two things and where kind of fat deposits are in your body. One of the big places where there's fat deposits is around your belly, right? Protecting your lower abdomen. Well, why do we have fat deposits there instead of in other places? Well, for our upper, our thoracic cavity, the upper part of our thorax, our chest, we have a rib cage to protect our lungs and our heart. So we don't need as much fat there. But around our belly, we don't have any bones that are protecting against physical shock. And so we need some layers of protections. That's one of the places where we deposit a lot of fat. Because what's it protecting? Well, it's protecting our digestive system, which we need, and it's protecting our reproductive system, which is there's a biological imperative there in terms of evolution and desires to reproduce and things like that. And so we have a lot of physical protection there in the absence because we have an absence of a real skeletal protection system there. And then also heat loss, especially around our belly. That makes sense because there's so many different organs. There are many different blood vessels, arteries and veins that we also, as the blood is going through them, we could lose a lot of heat. And so what we do is we're going to put layers of fat there, which helps to protect against that heat loss. All right, so we're going to finish there. That's about 9 minutes. So we will finish here and we'll pick up on point 4 on our 6 functions of lipids tomorrow. Great. Thanks so much and have a great day.